This is Math 409, Math 409, and we're going to start talking today about dividing with a two-digit divisor. So we've talked about our division. A lot of times people refer to this as long division, where you put a number out here and you want to. So here you want to say 400. Divided by 2. You're taking 400 and you're dividing it by 2. You're saying how many times will 2 go in 400? Well, we've been doing that. But what happens if we want two numbers out here instead of just one? If our divisor is two numbers. Well, that's not too bad. Let's just start with the number 18. Okay? So we've got to kind of estimate. Some of this is estimating trial and error when you start doing this. Well, we know that 18 cannot go into 4. So we wouldn't put anything by the 4 there. We put a 0. We don't need to put anything. We're just going to go to here. Can 18 go into 40? Yes, it can. Now we've got to figure out how many times can 18 go into 40? Well, you could estimate. You could say, well, this is almost 20, and we know 20 will go into 40 2 times 20, 40, 60, 80, if you can count by 20s. So we could start with a 2, and we'll put a 2 up here. Now remember, what happens is when we multiply this down here, then it's got to be smaller. This number needs to be smaller than that number. And after we subtract. So we multiply, that number comes here, we subtract, and then whatever number we end up with has to be smaller. If it's not smaller, then we've made a mistake up here. And we'll just have to work our way through it. So let's multiply. So we've got 18 times 2, or 2 times 18. So to do that, you can think 18 times 2. Remember, so we take our 2 times 8 is 6. 16, so you put your 6 and carry your 1, and 2 times 1 is 2, plus the 1 is 3, 36. Now you can do it that way, or you can learn to do it this way. 2 times this first number is 16, so you come right underneath here and you put your 6, carry your 1 right here, and then 2 times 1 is 2, plus the 1's 3, 36. So you come out with the same answer. You just learn to envision it going from here to here instead of having to go to the side and do it. So you take the 2, you multiply by the first number in the 1's place, the number in the right, in the 1's place, and you would come over here and put it underneath, line it all straight up underneath here. Carry whatever number you have to, then multiply by the 10's place, and then add that to it, and then get 36. All right, now we're going to subtract this, and we're going to get 4. Well, is 4 less than 18? Yes, it is. So that's great. So now we're going to take our 0. We're going to bring our 0 down. Then we're going to do this again. How many times will 18 go into 40? Well, it's the same thing here. 18 went into 42 times. Here we're going to say 18 and 40 is going to be 2 more times. So we're going to say 2. And we're going to multiply the same way. We're going to go 2 times 8 is 16, so we put our 6, carry our 1, it's already here, but we'll just carry our 1. 2 times 1 is 2, plus the 1 is 3, 36. We're going to subtract, we have 4. There's nothing else to bring down, so that's our remainder. So that we're going to have a remainder of 4. So it's the same steps, everything's the same, except it just takes you maybe a little longer to figure out where will this number, what will it go into. So let's try one more. Let's time 12 divided by 185. Okay? Let's pick some numbers here. So the first thing you do, you've got 12 here. Will 12 go into 1? No, 12 will not go into 1. Will 12 go into 18? Yes, 12 will go into 18. How many times? Well, that's pretty easy to figure out. 12 will go into 18 one time. If you went 2 times, you would be much bigger than 18. It would be too big. I'll show you that though. Let's just say we tried 2 times. Well, 2 times 2 is 4, and 2 times 1 is 2. Well, now we have to subtract. Well, 24 is bigger than 18, so we can't do that. So we know that 2's too big. So if you do that, that's fine, just erase, because that will happen in some of the other problems that you work that are not as obvious, and you'll have to just, like they erase and try again. So anyway, so we're going to 1 time. 1 times 2 is 2, 1 times 1 is 1, so of course 1 times 12 is 12. You're going to subtract, and you're going to get 6. Okay? Now, will 12 go into 6? No, so but we've got 5, so we bring down our 5. Now, this is another one. This may be an example of, you may not know on the top of your head how many times will 12 go into 6 without going over. So, you could, here again, you could try to estimate, well, what's 12 close to? You could say, well, 12 is just a little bit more than 10. And 10 would go into 65, 10 times 6 is 60. So that might work. 6 may work, or it may be too big. Let's try it and see. So let's try 6. 6 times 2 is 12. So we put our 2. We carry our 1. There's 6 times 1 is 6 plus 1 is 7. 72. So 72 is bigger. So 6 is too big. Okay? So even though we kind of tried to estimate and say 10, we go that 6 times, well, by the time you add those 2's to it, it's 10 times, that just adds, or 6 times, it adds too much to it. So we could try dropping it down just 1. Maybe if we just drop it down 1, it would work. Okay? So 5 times 2 is 10, so we put our 0, and we're going to carry our 1. 5 times 1 is 5, plus the 1 is 6. So it looks like that's going to work. That's 60. Now let me just show you what happened if you wouldn't have known at all what to do here. And let's just say you just started with 4. 4 times 12 is 48. 4 times 2 is 8. 4 times 1 is 4. It's 48. Now, when you subtract that, of course you'd have to borrow here, because you can't subtract 8 from 5, so you make that a 15, so we make that. So we end up with a 7. Well, look at that, that's a problem. That is bigger than that. So what does that mean? If this number is bigger than this number, that means that number could have gone one more time. Okay, so let's just go back and fix this again. I just wanted to make those little mistakes kind of on purpose for you, so you can see what happens if you're working on and you make a mistake. That's very typical, so you just have to go back and try again. So we said 5 was going to be the number. 5 times 12 is 60. 5 times 2 is 0. Carry the 1 is 5. Let me slow this down for you. 5 times 2 is 10. Put the 0, carry the 1. 5 times 1 is 5, plus the 1 is 6. You'll learn later in life, as you do more and more of these things, some numbers are very useful to know, like 12. There's 12 months in a year. So what if you do something for 2 years? Well, that's 24 months. If you do something for 3 years, that's 36 months. So you learn your multiples of 12 later. If you haven't learned your multiples of 10s, 11, you should know 10s. But if you don't know 11s and 12s yet, you'll eventually learn your multiples of up to 12 by memory. So we're going to subtract this. We end up with 5. 5 is smaller than 12. There's nothing to bring down. There's nothing else to bring down. So that's our remainder. So we put a remainder of 5. Okay, now sometimes you will be asked to write your remainder as a fraction. And so let's just take this problem right here, and I'll just show you how to write your remainder as a fraction. And then we'll do another problem. But you've got a remainder of 5. Instead of putting R5, you could put this number 5 over your divisor, 12. 5/12. So the answer to this problem would actually be 15 and 5/12. That would be your remainder here. Instead of saying a remainder of 5, you can take your remainder, put it in the divisor, and then you just have a number. The exact answer to this problem, 185 divided by 12, the exact answer is 15 and 5/12. Okay. So let's try another one like that. And you don't have to have, you can do that with the 1-digit one. If I have 7 there, if I'm going to take 24 and divide by 7. Okay, well, 7 will go into 24 how many times? Well, 7 times 3 is 21, so that's probably going to be it. 7 times 4 is 28, that's going to be too big. So I'm going to go 3. 3 times 7 is 21. I'm going to subtract, and I've got 3. There's nothing left to bring down, so I've got a 3. I could put remainder 3, but instead of putting remainder 3, I'm going to list it as a fraction. I'm just going to put 3/7. You take whatever number you have left, which will be your remainder, and put it over the divisor, and that is the exact answer, 3 3/7. Let's do one more. We'll do one with 2 digits. Let's go with 10. Let's put a 10 out here, and let's put 55 in here. All right, so 10 will go to 55. Well, this is an easier one. So 10 will go to 5, of course, but 10 will go to 55. We know 5, it'll go 5 times. 5 times 10 is 50. 10, 20, 30, 40, 50. So we're going to put 5 up here. 5 times 10 is 50. We're going to subtract that, and we'll end up with 5. So our remainder is 5, or we could just put 5 over 10. So our exact answer for this problem will be 5 5/10. Now later on you'll learn we can reduce these fractions, but we're not going to deal with that right now. We're just going to leave this as is and say that this is okay. Later, this 5/10, as you study your fractions more, you'll know that you could also call this 1/2. So, but you don't have to worry about that at the moment. That will come a little bit later. All right, so that is how you divide fractions with 2 divisors, with a double-digit divisor, I guess you could say, and also how to write your remainder as a fraction. Instead of calling it a remainder, you would just write it as a fraction to get the exact number. So let's talk just two more little things here we'll talk about that's not difficult, that you'll also be dealing with this week. We're going to learn to add fractions as long as the denominator is the same. Remember, we've got numerators on top and the denominators on the bottom. So the 3 is the denominator. What if I wanted to add 2/3 plus 1/3? Well, if my denominator is the same, we call that a common denominator. They're common, they're the same. And to add fractions, they have to be the same. If the denominators are different, you have to find a common denominator. And later we'll learn that. That's something else you'll learn later on too. But for now, we've got common denominators. The denominators are the same. Makes it really easy. All you have to do is add the top number. So 2 plus 1 is 3. We don't add these. We just keep our common denominator, and that would be 3/3. Okay, so you don't change this, you don't add these. If it's a common denominator in your answer, it's still going to be whatever that common denominator is. All you do is add your top numbers. Okay, so if I go with 2/5 plus 2/5, well, I've got a common denominator of 5, so it's going to stay 5, and all I have to do is add my numerators. 2 plus 2 is 4, 4/5. Almost too easy, right? So let's try 3/8, and we're going to add it like this. We're going to draw them like this. 2/8. Okay, well, I've got a common denominator. My common denominator is 8, so my answer is going to have an 8 on the bottom, and I'm going to add the top numbers. 3 plus 2 is 5. So you may see the problems written like that also. If I have 6/9 plus 1/9, okay, I've got a common denominator of 9, so my answer is going to be down here 9, and I'm going to add my 6 plus my 1, it's going to be 7. 7/9. Okay, you try to work this one. If I go what do you end up with when you work that problem? All right, that problem, you've got a common denominator of 6. You've got a 6 on the bottom. You're going to add the 3 plus the 2. That's going to be 5, 5, 6. Okay. Now, this works the exact same way for subtraction. Subtraction, if you've got a common denominator, all you do is subtract. So let's go back to our original way. Let's go with 2/3, and I'm going to subtract 1/3. Now, I still have to have a common denominator to subtract, and then, so I leave my 3, and then I subtract the 2, subtract 1 is 1. So the answer is 1/3. If I have 3/5, and I want to subtract 1/5, well, I've got a common denominator of 5, so I just need to subtract the 3, subtract 1, which is 2, and I'll leave my 5 on the bottom, 2/5. Okay. And then you can also write them this way like we did the other. Let's take 5/9. Let's subtract 4/9. And you've got a common denominator of 9. That's on the bottom. 5 subtract 4 is 1. Okay, let's do one more for you to do. Make sure you've got this. Let's go with, we could go with a bigger number. We could go with 8/15. And we could subtract 5/15. Now, if we did that, you would do it the same way. You just have a bigger number on the bottom. So pause this, see if you can work that, see what you come up with. Okay, on this one now, I've got 8 minus 5 is 3. I've got a common denominator of 15. So I'm just going to put 15 there, and my answer will be 3/15. Here again, some of these fractions that we end up with, we can reduce and make them into smaller numbers later. But we'll worry about that later. We're not going to deal with that in a moment. Okay, so that is how to add and subtract fractions with a common denominator. And that was a good review on division and how you divide with 2-digit divisors, and also how you write your remainder as a fraction. If you need to go back and watch any part of this video as you work on your assignments this week, you can go back and just watch the sections that deal with the particular assignment you're working on.